This video is about the substitution at the carbonyl with organometallic nucleophiles. Similar to lithium aluminum hydride, Grignards, for example, can also react with practically all carbonyls. However, after reacting once, causing a substitution to occur, you form a ketone. We know that Grignards react with ketones, so therefore we usually get an addition reaction also. This turns out to be an extremely effective way of making alcohols that have two of the same alcohol group attached to it. I would also like to point out, notice the carboxylic acid. You require two equivalents of Grignard initially because of course one equivalent is going to be reacting with the proton, because recall Grignards cannot be in the presence of protons because they are also strong bases. Let's look at the mechanism of a Grignard reacting with an ester. Initially, the Grignard just attacks the ester at the carbonyl and does a substitution reaction, kicking out the ethoxide, forming a ketone. This ketone now undergoes nucleophilic addition of a second Grignard to yield us a tertiary alkoxide, which then needs to get protonated to form our tertiary alcohol. You're probably wondering, can we make a secondary alcohol this way? And the answer is yes, we can, as long as we have a formal ester, i.e. it's like an aldehyde, but it's an ester. The initial substitution forms an aldehyde, which then undergoes further addition to form our secondary alcohol upon protonation. Now you might be wondering, can we stop at the ketone and make ketones? Well, short answer, yes, we can. Two different ways. The first way is to use copper Grignards. Of course, these are weaker nucleophiles, so they will react with, say, acyl chlorides, but they will not react with ketones. Hence, we will stop after we have formed a ketone. The second method is to react a Grignard with a nitrile and then hydrolyze the intermediate. Here are some practice problems. Pause now. Here are the answers.